Hello everyone, welcome back to lesson number 17 for Calculus BC, and in this video we're going to do special integration techniques that involve using the arc sine on the arc tangent. Alright, so I'm going to show you guys 3 examples of this, and then in our 5th video we're going to do just a couple more integration techniques for this lesson. So example number 6 I'm going to do in the next video, so we're going to skip over here to example number 7. So we're going to do examples 7, 8, and 9 in this video. So if I integrate the 1 over x squared plus 6x plus 13, then what we understand here is that if we did u sub, right, we made the denominator u equal to x squared plus 6x plus 13, then our derivative would be 2x plus 6. And that's not anywhere to be seen here in this function. We have a random 6x here, because if the 6x had been gone, it'd just be x squared plus 13, then arctangent is what we'd want to do. So another thing that we can try to do here in the bottom is completing the square. So this example that we're now going to learn is how to complete the square. Now, hopefully we know how to do that already from previous math courses. So we're going to do 2x plus 6x plus blank, all right, plus 13 minus blank, right? We can't just randomly add a number here, so we have to add it and subtract it. And so by completing the square, and I'm going to do a really quick tutorial on completing the square, is it's an x squared to 6x. This number we're doing here is you're going to take the b term, or the term in front of the x, you're going to divide it by 2, and you're going to square it. All right, so you're going to take 6 divided by 2, which is going to be 3, and then you're going to square that, and that's going to give you 9. So if I do plus 9 here, I also have to do minus 9. So if I were to simplify the denominator, then I would still get this back. Right, so I'm adding 9, but then I'm also subtracting 9, and that is supposed to be a 9. So then we want to combine this. We want to combine this right here as a square. Now you guys could factor this. You could say, okay, well, x squared plus 6x plus 9, and factor it. Or just remember it's just going to be x, whatever the b term is going to be here. And then you can think about this number in 2 different ways. You could take b and divide it by 2, or you can take the 9, the c term, and you can take the square root of it. So this is x plus 3 quantity squared, and then I'm going to do plus, and I'm going to get 13 minus 9, which is going to give you 4. Now this example works out nicely because this is a perfect square. It doesn't matter. This could be 7, and it's still going to work out. And just like in the previous video, ladies and gentlemen, you realize we have 1 over a function squared plus a number. Now, in the example I did in the previous video, I did the number plus the function squared, but you guys know as well as I do that a plus b is the same thing as b plus a. So as long as you have a function squared plus a number in the denominator, no matter which one's, first and second, we're good to go. So this is an arctangent. So we can recognize that this is an arctangent. So I know right now this is going to be the arctangent. And so we're going to really quickly write out what that formula says right here. So I need to know what parts I have. Well, I have to remember I have the 1 over a. That's really, 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 really important. 1 over a. So just like we did before, u squared is going to be equal to our function squared, and then a squared is going to be equal to our number 4. And so it doesn't hurt to do this out here for a minute, because a lot of students may think this is 1 over 4, and it's not, right? It's 1 over a. And remember, a squared is actually 4. So we're going to get u is going to be equal to x plus 3, and then we're going to get the a is going to be equal to 2. And even though we don't need to do it for this example, it's always really good practice to write what du is. The derivative of x plus 3 is just 1 dx, so we don't have to worry about anything else up there with this. And now that we have all of this information, ladies and gentlemen, we're able to solve this problem based on the video I just talked about before. So this answer is going to be equal to 1 over a, which is 2. We already know it's going to be the arctangent, and then it's going to be u over a. So it's going to be x plus 3 all over 2 plus c. So that's one way of doing this problem where you guys will get the arctangent. So again, remember 1 over a, arctangent of u over a plus c. All right, so this is what we did by completing the square. So that's another strategy that we can work on. Now, question number 8. Question number 8 is very tricky because you actually have a variable in the numerator. Right? You see this and you're like, oh, all right, well, I see this is going to be the square root of 1 minus a function squared. And again, if you want to do u sub, this is not going to work, right? The derivative of negative t to the 4th is negative 4t cubed. Well, we're missing a t squared up here, right? If this had been a 3, then we're good, u sub, u sub, u sub. But we're looking at this. So u sub does not work. And we can't split the denominator. So we're like, well, we do see a square root. And we do see a number minus another number, another function squared. So possibly this is arcsine. Like possibly this is arcsine. You know, maybe it's arcsine. And so let's go ahead and play with it. Let's see what we can do with this question. So u squared is going to be equal to t to the fourth. Again, it's what's the function after the negative. And a squared is going to be equal to 1. And then u is going to be equal to t squared, and a is going to be equal to 1. Now this is why du is so important, because when you take the derivative of u, you're going to get 2t dt. Yes, that's why the t is there. This is an arcsine. It is. Because sometimes, guys, when you take the derivative, it's not just going to end up being a number. There's going to be a function here. So what led me to possibly thinking this is arcsine is that u sub doesn't work, and the fact that I've got a square root in the denominator, I got a number minus a function squared. So arcsine. And so I have 1/2 du is equal to t dt. And so when I do this problem now, all I have to do is write the 1/2. I clearly know, remember the 1/2 is for what's right here, right? Remember, arcsine, there is no 1 over a. So it's going to be 1/2. I'm going to go ahead and do arcsine, and it's just going to be u over a. So it's going to be 2 squared over 1 plus c, and that's the answer to this problem. But we wanted to show you guys an example like this because you can say, well, it can't be arcsine because, again, there is a variable inside or on the top of the integral. But again, when you take this derivative of u, you may see that variable pop right up there. We need that t in order to do this arcsine problem. If that t wasn't there, then we wouldn't be able to do this question with arcsine. We would have to do something else. All right? So that is another example of that. Now for question number 9, I'm going to put it on the page for us so we can do it. Let's do it here. So I just moved the question over here to the next page. So we want to take the integration of x plus 2 over the square root of 4 minus x squared. So like before, ladies and gentlemen, if you do u sub, right? So if you look over here and say, okay, let's do u sub. U is going to be 4 minus x squared. Your derivative is going to be equal to negative 2x dx, right? Well, there's an issue with this problem because we have the x, but we have this positive 2 here. So we can't do u sub initially on this problem. The other thing you guys can look at is, well, we do have a square root. We have a number minus some function squared. So if we take the derivative of negative x squared, we get 2x. Again, same thing as before. We have this pesky little 2 we have to deal with. So what if we could do a technique that we have done many times before and split the numerator? And that's exactly what you're going to be doing here. We're going to split this thing. We're going to go ahead and take our function and we're going to split it. Okay? Which we can. All right? If we were to get a common denominator, if we add these up, we would get this right here. So this is absolutely wonderful. And now that we've done this, then I can now take this and realize, oh wait, this is now u sub. This left side right here is actually going to be u sub. So I can go ahead and start applying that to this particular problem. So let's go ahead and continue on with this. So now that I know this, I need to then pull out, a negative 1/2, and I'm left with x dx, right? Which is exactly what I wanted. So u is going to be 4 minus x squared. Du is going to be negative 2x dx. And so go ahead, 1/2 du equals x dx. So this is going to be the du. And this right here is going to be the u. So if I pull out the negative 1/2, right, if I pull out the negative 1/2, then I'm left with du in the top, and I'm left with the square root of u in the bottom. Okay? And that's awesome. This is a really straightforward, it's not obvious at the beginning of the problem to do it this way, but this is what we're going to do. And we're going to be left with, 1/2, negative 1/2. Then we're going to integrate. This is going to be u to the negative 1/2 du. Right? This is really just 1 over the square root of u du, if you want to think about it like that. And so let's integrate this, and we're going to get negative 1/2. We're going to get u to the 1/2 power. So remember, we divide by 1/2, we really multiply by 2. And then the plus c will come later when we finish the rest of the problem. So this is going to end up being negative u to the 1/2, which is going to be equal to negative, and then u up here is going to be the square root of 4 minus x squared. So this integration that you see right here is going to be negative square root of 4 minus x squared. So that's the first part of our problem. Now, up here in this top one, well, we can look at this and say we have a number, which we can absolutely pull out. Right, we can absolutely pull this out. And then hopefully you guys are seeing what I'm seeing here, that, okay, well, I've got 1, some number, over the square root of some number minus a function squared. So hopefully you guys realize that this is going to be an arcsine problem, right? Arcsine problem, where u squared is going to be equal to x squared, and then a squared is going to be equal to 4. U is going to be equal to x, and then a is going to be equal to 2, and then du, again, practice this, it's going to be dx. So in this case, it doesn't matter, but we still want to make sure we do this, because if this has been a constant, we want to pull that out. So then when we do the problem, we have our 2. We're not pulling anything out right here, so we have our arcsine, and then remember our formula is just going to be u over a. So it's going to be x over 2, and that is our solution to this problem. So then down here, I can put them all together, and I can say that it's going to be negative square root of 4 minus x squared plus 2 arcsine of x over 2 plus c. So rewriting your function, splitting your numerator is actually helpful, but then it just becomes a little bit more of a pain because you not only have one question, you have to solve both questions. So if you guys can't figure something out, you can absolutely split your numerator and then say, oh, well, this one's going to be u sub now because I'm just dealing with the x, and this one's going to be an arcsine. And sometimes it can be an arctangent as well. It's not always going to be this. Sometimes it's a natural log. So a lot of times, it depends on what the function is, but at least you can independently solve the problems and put them together at the very end. Okay? So I hope that those videos were helpful for you guys. We're going to come back in our 5th and final video for this lesson and talk about a couple more integration techniques. So I'll see you guys then.